everyone, welcome to my channel. Tech Girl is again here with some amazing concepts of coding. So in my previous video we have discussed Kadane's algorithm. If you haven't seen it yet, I have given the link in the description, so check it out. Talking about in this session, we will get our hands dirty with a coding problem based on it. Let's get started. We are going to discuss K-Concatenation problem, which I have taken from CodeChef. I have shared the link of the problem in the description so that you can also do hands-on along with me or after me. So if you remember, in Kadane's algorithm, we try to find out the maximum sum subarray. Talking about the problem statement of this K-Concatenation, here we are given an array and number of times this array is going to be repeated or concatenated. After that, we have to find the maximum sum subarray of the newly generated array. So, talking with some examples. So, as you can see on the screen, we are given with an array containing elements 1 and 2. And the number of times it is going to be repeated, that is k equals to 3. So our resultant array will something look like 1 2 1 2 1 2. So as we have to calculate the maximum sum subarray, in this case our output will be 9. How I am reaching to the output? 1 plus 2 plus 1 plus 2 plus 1 plus 2, which is equals to 9. So this is our maximum sum that is possible from this resultant array, and this makes our output to be 9. Now let us see about the constants. So in this case, constant is n, that is ranging from 1 to 10 to the power 5, which means the size of the array can range from 1 to 10 to the power 5. K, which is the number of times the array can be repeated, is also ranging from 1 to 10 to the power 5, while the elements of the array will range from minus 10 to the power 6 to 10 to the power 6. So let's first try to apply brute force approach to our problem. From the constants, you can see that if the time limit of the above problem is only 1 second, then we can't apply O(n) square approach. Why? Since 10 to the power 5 to the whole square will result into 10 to the power 10, right? So as you know that we can't apply O(n) square approach since the time limit is 1 second, because 10 to the power 8 inputs are processed in the system in 1 second. So how the system is going to process 10 to the power 10 inputs? So this means that O(n) square approach can't be applicable to our problem if the time limit is 1 second. So what brute force approach says that, first, as the problem says, we are given with an array and we will append the array k number of times as suggested in the problem, and after that we will try to calculate the maximum sum subarray using Kadane's algorithm. So if you analyze it in more better way, you will come to know that the time complexity of this algorithm will result into big O of n, and n multiplies by k. So if you can see that this will 10 to the power 5 into 10 to the power 5. So this will result into big O of 10 to the power 10. Oh no, this creates the problem. We can't apply O(n) square approach in our problem because this will lead to time limit exceeded thing. So we have to think a little bit more. If you can think, the most base case will be if k is equals to 1, that is array is not going to repeat, then Kadane's will give the maximum sum subarray, right? Because we know that Kadane's algorithm gives maximum sum subarray for any given array. So for k equals to 1, I have no problem, because and our algorithm will run 10 to the power 5 times in the maximum cases. So this will not create time limit exceeded condition. For k not equals to 1, we have to think a more deeper. Suppose this is our array containing negative elements as well as positive elements, and suppose it is repeated for k equals to 2 times. Suppose it is repeated for k equals to 2 times. So if you think deeper, what will be our maximum sum? Suppose the overall sum of this array is greater than 0. So you can suppose the sum of this whole array is greater than 0. So the possibility of getting maximum sum sub array, one will be the Kadane's algorithm, right? One will be the Kadane's algorithm. This can be maximum sum possible, like after repeating I am not getting maximum sum, this array will be giving the maximum sum. So one answer could be Kadane's algorithm. What would be the another answer? Suppose this array is repeated 2 times. So if you imagine it in like this way, that this is our array, and if I have found the best of prefix sum and best suffix sum, prefix sum starts from the beginning of the array and suffix sum starts from the ending of the array. So what is the best sum possible from the beginning of the array, and what is the best sum possible from the end of the array? So another answer, if the sum is greater than 0, will be best suffix sum of any array, best prefix sum of any array. And since I have already used two number of array for getting the best suffix sum and best prefix sum, so our remaining sum will be from k minus 2 number of array. So k minus 2 into sum plus best prefix sum and best suffix sum will give us the maximum, can give us the maximum sum subarray. So we have two options, either this could be maximum or this could be maximum for sum greater than 0. I will try to explain you with more examples. So let's say our array is repeated 2 times. I have repeated, this is our first time and this is our second time as per the problem. Now I'll try to find out the maximum prefix sum and maximum suffix sum for this given resultant array, or no, not for resultant array, for the given array. Maximum prefix sum will be 5 here. How? You can get that 5 minus 2 in this time 5 have maximum sum. After that minus 2 came, our sum got 3. After that minus 3 came, so our sum got 6. So this is updated to 6. After that 4 came, so it is updated to 10, and here it was 10. Then minus 1 came, it is gone to 9. After that 2 came, so it got to 11. After that minus 4 came, so it is updated to 11, and then minus 4 came, so 8. So our maximum prefix sum is 11. Sorry, it is 11. Maximum suffix sum, in our case, maximum suffix sum will also be 11. So now we will continue to apply our formula on this problem. Here, if you apply the Kadane's algorithm to this problem, it will result into 11 maximum sum. Now we will try to find out what will be the maximum sum that I would get from MPS plus MSS plus k minus 2 to the total sum. Okay. Voila. So you can see here we are getting maximum sum using our formula. That is, maximum prefix sum is 11 plus maximum suffix sum is 11, and since our k is 2, so this won't create any value to our problem. So 2 minus 2 into total sum will be 0, and 11 plus 11 results into 22. So we are getting a maximum answer. Now we will have to think about what if sum is less than 0 or equals to 0. So if I symbolize the problem, here I have an array of elements and k is equals to 3. So since in this situation the sum of these elements that is inside a single array is less than 0, but there could be the possibility that this sum could be positive, right? Suppose the elements of array is only negative in the mid, and here it is positive, here it is positive, here it is positive, here it is mid, and here it is positive. In the mid it is negative. So overall it is negative, but there could be a chance that this could lead to something positive result or something more positive result. So there could in this case of sum less than 0, there is also two possibility. Either Kadane's sum is maximum, or there could be the possibility that this could be the maximum. So this is nothing but best prefix sum plus best suffix sum. Now you got that we have to just calculate best prefix sum and best suffix sum in the array and the total sum and Kadane sum, and the calculation of these four things will leads to our solution. So let's see how we are going to see the solution through the code. Okay, so for solving our problem, we are in the need of four things: total sum, Kadane sum, maximum suffix sum, and maximum prefix sum, right? So let's first calculate Kadane sum. For Kadane sum, as you already know the algorithm, as we have discussed in our previous video, if you don't go through it, you can check the link discussed given in the description. So why I have taken long here? So since, as you know, that our input ranges from 10 to the power 5, I mean from 1 to 10 to the power 5, so it goes mandatory for us to take long, otherwise we may miss some input because of overflow. So firstly I have taken long, and then we are getting the array and the size of the array. After that, the maximum ending here will be 0, and maximum so far is the end mean. I have run a loop. After that, I am calculating the maximum ending here by adding the ith element of the array, and then I am comparing if the maximum so far is less than maximum ending here. I am just updating it, and also I am checking that if it is going to be less than 0, make it 0, because if the array has only negative elements, we won't take any element and the maximum sum will be 0. After that, we are returning the maximum sum so far. So this is our Kadane sum. I'll not go much deeper into it because we have already discussed it. Now, talking about the main function. So this is our function through which we are returning the maximum subarray sum for the K-Concatenation problem. Here we are getting the array size of the array and the number of times it is going to be concatenated. I have stored this Kadane sum in a variable named Kadane sum through that function, and I am checking if the k is 1. That means we are not going to repeat it many number of times, and I am just returning that Kadane sum to our problem, as we have discussed. Now, the major problem arises here when the k is not equals to 1. So I am taking CPS. Here stands for current prefix sum, current suffix sum, max suffix sum, and max prefix sum. I am taking current prefix sum as 0, current suffix sum as 0, max suffix sum, and max prefix sum, since we haven't taken any sum yet, so initially I have initialized it with int mean, or you can also use long mean since our variable are in the long form. Now I'll run a loop from the beginning of the array to calculate the current prefix sum. Since prefix start in the beginning, to get the current prefix sum, I am just adding the current prefix sum to the with the ith element of the array, and after that I am checking if it is greater than the max prefix sum. I am just updating this is our max prefix sum. Since for calculating a total sum, I can also do that. I can run a loop and then I can calculate the total sum, but here I can also use this variable, since the value stored in this variable is also the total sum, since we are traversing from the first to last element of the array. So in this way I am not running another loop. I am just getting that value from the current prefix sum. So this is our total sum. Similarly, in the suffix sum, what we have to do is I will run a loop from the end of the array, and what I will do is for na-1 element to 0, I'll update current suffix sum is ith element, and after that I'll calculate the maximum suffix sum using that whenever it is greater, I'll update this maximum suffix sum variable. After that, as we have discussed, what I have to do is, if sum is less than 0, what will be our answer? As we have discussed, if the sum is less than 0, either, let me show you that page also so that you won't be confused. If the sum is less than 0, either Kadane sum or this will be the maximum. So Similarly, I have taken either the Kadane sum or maximum suffix sum plus maximum prefix sum will give you the maximum. Either of them can give you the maximum result. If sum is not less than 0, if sum is greater than equals to 0, our answer will be maximum suffix sum plus maximum prefix sum plus sum into k minus 2. Why k minus 2? Because we have already taken two array elements, array for calculating the maximum suffix sum and maximum prefix sum, and then sum into k minus 2, and Kadane sum can also be the maximum. So when whichever is the maximum, I will just put that value in our answer, and I'll return that answer to our problem, and that's it. We have got the maximum sum sub array after the K-concatenation in just how much time complexity? You guess and tell me. You have guessed right. So the time complexity will be just big of n. Just try it on using the Kodchef ID, using the Kodchef question, and submit that problem on the Kodchef. All the best, and I hope you will all get the correct result. Thank you. Do subscribe and comment and let me know if you have any problems so that I can discuss that thing in the next video. Thank you. Bye bye.